So I'm Paul Speciale. I'm the VP of Products for a company called Data. Data is a company that is a vendor in the object storage space. We've been present in the market for about 3 years. The company itself goes back a little bit before that. We're actually European in origin, so the company's founders are all based in Belgium, outside of Ghent, Belgium. And the origin of our technology actually comes out of academia back in the 2005 timeframe, out of the universities of Ghent and Leuven. The actual core technology that we've built is in the camp of data protection. It's an erasure coding mechanism. We'll make some references to that as we go through the presentation. The core thing that we want to talk about here, though, is not a product presentation. We really want to talk about big data. There was a panel this morning where we talked a little bit about big unstructured data, and this is sort of a little bit of a meat section on that topic itself, so I'll go ahead and dive into that. And I think the big thing we want to do here is kind of remove some of the ambiguation behind big data itself, right? There's big data for analytics, and then there's this big unstructured data. So we want to kind of contrast them and then maybe talk about optimal data management and storage strategies for each of them. So I think we all have seen studies about data growth coming down the pipe here. I think one of the most often cited studies is this one by IDC, where they're talking about zettabyte scale data, right? So people have heard about petabyte, terabyte, exabyte. Anybody know what a zettabyte is? So a zettabyte sits in between an exabyte and a yottabyte, right? So it's actually a million exabytes, 1,000 exabytes, 1 zettabyte. So the expectation is that we're going to see huge growth in data here in the next 10 years. But I think the bigger observation they're making here is that it's not only the amount of data that needs to grow, but there's a question of how we're going to manage all this, right? So we're facing this flood of data, but the other aspect of the study was that the number of people that are going to be around to manage it, the qualified administrators, is actually staying roughly flat. So think about a 35x growth in the data, but a 0.4 growth or 50% growth or so in the amount of data to manage it. So that means each administrator is going to be expected to manage something like 20 times more data if you believe these studies. So I think the core thing that argues is that there has to be some other element here that's going to help us out, right? And there has to be some element of automation, some degree of higher intelligence in the system so that we can manage these things with roughly the same personnel. If you look at that study in a little bit more detail, they start kind of digging down beneath the scenes and saying, what is the source of that growth, right? And what they find is that a lot of it is driven by unstructured data. So this is something that we've talked about for quite a long time, right? Unstructured data, file-based data has been around for as long as I can remember. And it, I think, really caused kind of the transformation of the storage industry from the traditional sort of DAS, direct attached storage, and SAN, block-based world, to the world of NAS, network attached storage, right? People were dealing with a lot of office automation data, collaborative design data in the form of CAD. But now what we're seeing is that these files and these objects are just getting bigger and bigger and more voluminous, right? So really, I think this is sort of the key driver that we have to look at, is there's a lot of applications and a lot of industries that are starting to push the amounts of data that we're dealing with, the capacity points. We ourselves deal a lot with the media industry, so I want to draw that one out a little bit more specifically. But there's also a huge online component to this. I know that we're all familiar with the online photo sharing sites and the online video sharing sites. Medical imaging has been around forever, obviously with PAPS and all the different modalities that they drive. So there's just no shortage of application drivers. So we started really focusing ourselves on the media industry, and I think that's one where petabytes are really becoming the norm. It's actually very surprising to me. I've been dealing with storage for the last decade, and it wasn't even 4 years ago that you could go into an account and they would be looking at you like crazy if you said, we're selling storage that's optimized for petabytes. But I think the real driver in this industry now is these high definition formats, the 4K video formats, and then obviously the 3D formats, which double any of the numbers that you hear people talk about in 4K. So 4K video is sort of the gold standard in terms of the highest res that you'll see. The numbers that you hear about there are that files that they generate are around 3 terabytes per hour for 4K video. It becomes double that for 3D because they do left eye and right eye. What we're finding is that a lot of these companies are generating that video out of multiple cameras, so you hear about things like 30 terabytes per day, 50 terabytes per day for a single day of shooting. So that quickly adds up, and it's very easy to go and find accounts now or customers or productions where a petabyte is being accrued very, very quickly, even within the course of a single year. In fact, one interesting anecdote, I went to Paramount Studios something like a year ago. I think we all know the Dr. Phil show. Dr. Phil has a petabyte, right? So that kind of put it in context about how much data is being generated here. Okay, so I think the growth drivers are one aspect of that, but we really want to kind of distinguish what people are talking about here with big data for analytics and then big unstructured data. So big data for analytics is sort of the first thing we want to look at. And I think this has really actually been around for a while, right? So if you look back about a decade, people have been collecting data in the form of small log files for a variety of scientific applications for quite a while. We actually even heard about an agricultural application where they were putting sensors on plows and feeding those, that sensor data back in the form of small log files to a centralized repository. But we're seeing it all over, right? Travel industry, geographic, energy research. But really now in the last decade, we've seen kind of a flood of this data in the form of analytics for online applications, really creating sort of a new push of volume. And I think what we're seeing is that kind of data, as captured as sort of an aggregation of log files, is really starting to stretch the limits of the classical database world, right? And that has led to relational databases which were previously optimal, not being optimal anymore. The data is too big, it's too voluminous, the ingest rates, the velocity of the data doesn't fit anymore. And that really sort of started the spark behind innovation in the database space, and I think we see a lot of that here at the show. So Hadoop, MapReduce, a lot of innovation around that. And that's really what we think of as big data for analytics, and then the applications that let you query that, let you analyze that, let you visualize that is sort of the other part of that camp. So the other side of that then is what we're calling this big unstructured data growth, right? So this is data that is coming out of media, but it's coming out of many other industries. One of the things that we're seeing now is that what used to take months to generate in certain industries is now being done in days. And one example I can cite is in genomics. We've talked to a number of genomics accounts where sequencers that they used to sequence the human genome used to take months to generate that data. They can now turn that around in a day or two, right? And that kind of data gets, very quickly to terabyte scale individually, and then they need to archive that. So that ends up being a huge driver. But even within business, we're seeing corporations that have kept file shares online and sort of managed file shares by user, want to create sort of centralized repositories for sharing. They're starting to aggregate this type of data and drive very large loads. And then, of course, scientific. There's no shortage of examples inside energy research and others that are driving huge loads. So I think one of the key observations we've had is that fundamentally, big data for analytics and big unstructured data are different in the form of the data themselves, right? Smaller records, smaller log files versus these big files, and really big files. We're starting to see files now that are hundreds of gigabytes very commonly, but we're even getting requests now for multi-terabyte files, even 10 terabyte plus files. But there are differences, right? There's key differences here in terms of how the access patterns are going to work, how many objects we're going to manage. What we see here in the unstructured data world is that applications in the categories that I've talked about do start driving a need for millions of objects to be stored, hence millions of files. They start thinking about the access patterns in terms of ingesting that data very, very rapidly from a throughput perspective, reading it out at high throughput at multi-gigabyte per second rates. The classic solution for doing this has been file systems, right? So we talked about the growth of NAS 15 years ago, 20 years ago as being the engine for unstructured data. Those were great solutions. They continue to be great solutions. They have a fit within big data. But we do see applications where the file system itself is becoming a limitation. I've talked to accounts in media in the recent weeks where they worry about how many files they put in a folder, right? Because they know they'll have some kind of limit. They know that they'll stretch the capacities of a single host. They know that they'll stretch the performance limitations of single hosts. So the need to have systems that don't have these boundaries is certainly starting to present themselves in those three metrics. So what do we see customers doing, right? So I think it's kind of the story that we talked about a little bit on the panel I was on this morning. People want to keep this data around, but they view it as a cost center, right? They don't view it as something that can be monetized or something that has real business value until really recently. So a lot of times they end up looking for the cheapest possible solution to store it on, right? And the cheapest possible media, of course, is going to be tape. Ultimately, from a TCO perspective, there's still many other components to tape, right? You need to look at the drives and the libraries and everything. But by putting it on tape, what they're really doing is creating sort of dormant storage. And it's hard to go and figure out where the data is that you want. You don't have online access to it. Your latency of access can be hours, it can be even days, so you really need to know ahead of time. So the analogy that we're using is that this just becomes a clutter box, right? It kind of becomes like grandma's attic, and you know that you have this repository, but you really don't know how to make use of it, and you don't know how to extract information when you need it. So I think we're seeing a transition point now. We do see companies starting to think about this as being of more value. One of them is this sharing use case, right? So I can cite one example without mentioning the name. In the fast-moving consumer goods category, or FMCG is what they call it, we've seen companies that have done a lot of advertising, a lot of online asset creation. These can be small videos, they can be graphics. What they end up seeing is that they redo these things repeatedly because they can't find things that have already been produced. So rather than spending the time to find it, they simply reproduce it, and they find that the cost of reproducing it is high, but it's greater than going to find it. In many other cases, people have to keep this stuff around, right? There's regulatory or compliance reasons. But then there's sort of this idea that you can monetize assets that you have on tape. So what can you do to take a dormant archive that's on tape and sort of reactivate it and give it life and make it accessible for users? So that's really the thing that we're starting to see people do. And I'll talk a little bit about a use case that we've seen. So I mentioned it earlier today. I don't know how many of you saw the panel. But we're starting to see a lot of media companies that have these assets realize that they can pull them back and monetize them. The use case that's very interesting is, has anybody here heard of the Montreux Jazz Festival in Switzerland? Yeah, it's a pretty popular one. Sometimes I'll say Montreux and people will say it's the Monterey, but it's Montreux in Switzerland. It's actually a very popular jazz festival. The founder there is a very interesting man. His name is Claude Nobbs. And if people know the Deep Purple song, Smoke on the Water, that's a fairly popular song. I never knew about this, but Claude is mentioned in that song. There's a line in the song where it says, Crazy Claude was rescuing kids from a fire. So there was a fire at some point at one of the festivals. Claude ran in and out to rescue people from that fire. Well, Claude ended up recording every concert for every year, and he ended up with 5,000 hours of video. And he's a technology geek, so a lot of this is pretty high fidelity video, but where was he keeping it? He was keeping it on tapes, collections of videotapes, newer generations of tapes more recently, of course, but he was keeping them in his villa. So there was absolutely no real data integrity, no data durability, and moreover, no ability to really reach in and find things and monetize them. So we started working with him on a project to really digitize that and to archive it on an active archive. And there were really three aims, right? One is to really protect the data, to make it secure. He's got these things on these old corrupting videotapes. Secondly, to make it more live, right? So that he can have researchers go in and access the data. There's a lot of metadata around it in terms of history and documents. But thirdly, to monetize it. And he monetizes it in the form of creating Blu-rays and selling them. And thirdly, in terms of creating a series of jazz cafes. So they have one today at the Geneva airport, they have one in Paris, and they have one in Zurich. But I understand there's one in the works here in New York, where you can go in, sit down, have a meal or a drink, and actually stream the concerts to your table. So that's the way he's sort of thinking about monetizing these once dormant assets. So the question is, how do we do this in a cost-efficient way, right? Because I think we know that tape is really cheap. Tape has a lot of benefits. So we need to start thinking about how to do this in a more online manner. So tape we think has a place, right? It is a difficult option in some respects, though, right? Access latency is one. We talk to customers where they say, if we have something on tape, if we know about it a week ahead of time that we'll need it, it works fine. So they have a sort of this planning phase where they know they need to get access to it. Data really should be always online, right? That's the other argument for doing this on disk, is to make it possible to get something sort of immediately. We'd like applications to be able to talk to the data, right? So this is the kind of under that heading of smart applications that understand how to sort, understand how to categorize, understand how to analyze the data, and also to retrieve it. We really need something that's sort of a direct API into the system. And then we want to get rid of these scalability limits that we dealt with in the past, right? So the per host limits in terms of file systems, the per directory limits. We need to think not only about petabyte scale, which is very common today, but we need to think about exabytes in the future, because we're seeing the day of the exabyte coming. And then how do we protect that data, right? What's the way of making data very highly durable and protecting the integrity, right? If you're talking to a media company that has sort of their last version of their media assets on their final copy of videotape and they're digitizing it, you really need to protect every bit. You need to make it bit perfect and keep it bit perfect in that sense. But then to do all of this in a super cost efficient way, right? So that you're not scaling up cost as you're adding capacity. So one of the things that we are very focused on is sort of addressing those requirements. And one of them is to do this on disk, so that we have this online access, very low latency access to this big data. To do it through a wide series of APIs, right? So APIs that are application specific in languages, and also those that are a little bit more standard. So we'll talk more about that. And then taking a look at sort of this data durability equation in a really fresh sense, right? We're doing things very differently now. Obviously, managing petabytes and tens of petabytes and exabytes is a very different equation than it was to manage gigabytes and terabytes. So we need to think about that. There are alternative schemes for storing data. There's been, obviously, RAID has been the standard for years to store data on disk. There are replication schemes. There are mirroring schemes for keeping data durable. There is a new camp. There's also what the industry calls erasure coding, which is sort of a fresh approach to storing data in a very durable manner, especially on very high density disk drives. So all of those things added up together is what we call optimized object storage. So I wanted to talk a little bit about that more. A couple more points on tape. I think with tape, there is a huge benefit that people do take advantage of, right? And that's the low to zero power aspect of tape. You can put data on a tape, you can pull it out of a library, and effectively you have a zero power requirement. You are paying a price for that in terms of access time. There are some other considerations, right? People put a copy of data on tape. You really can't live with one copy. You have to worry about media errors and media integrity with tape, and especially over a certain lifetime. You really want to mirror that. So you start doubling your costs immediately when you start thinking about keeping things in a very reliable fashion on tape. And then how do you do data integrity checking, right? If things are on a shelf somewhere, do you need to pull the tapes back periodically, look at the integrity of the data, and then potentially rewrite it over time? So these are very big projects, right? You need to have people that are thinking about this all the time to manage the migration. That's another key aspect with tape. Every generation of tape is sort of only compatible one step back. So if you have LTO4, you have to start worrying about how to manage that and put it onto LTO6. So you have this constant moving format problem that you have to manage. With that said, we think there's a role for tape, right? Sort of as perhaps the final copy, but it's a minimizing role. File systems. So we talked about file systems in terms of scalability limits, but what about from a data organization perspective, right? Many of us manage our own personal photography. I used to put it on my Mac and start thinking about it as I've got all my images for 2011, 2010, 2009. I have a folder for each one. Then I do it by month. Then I do it by location or event. It gets very time consuming, right? So what we're seeing now is a transition to where people are letting the application manage that more smartly. So if you look at things like Google Picasso, which I mentioned earlier this morning, really what you do there is you dump your images into a big bucket, right? It's a big object storage bucket, and you don't worry about the organization. You let the application manage that. So those of you that use Picasso know what I'm talking about. There's geotagging and there's time-based organization that it takes care of there. But really the key there is that the intelligence has been shifted to the app rather than in the file system, and that you sort of have this big bucket of object storage that can scale sort of without bound to manage these huge repositories. So instead, object storage, rather than dealing with things by folder or by directory or by hierarchy, it starts thinking about things as big buckets, right? That's the way that Amazon S3, for example, presents storage. We can do that now in storage systems themselves. So the idea of a namespace where you can store hundreds of thousands, millions to billions of objects without limitations and not worry about the boundaries for that. Now with that said, people still think about things in terms of file system hierarchies, and many applications do. So there is a transitionary process, and there are gateway technologies that can manage bridging current applications that think about file system hierarchies into kind of these object storage approaches. So that transition does exist. Petabyte, so let's talk a little bit about scale. I think petabyte, we've talked about petabyte being normal today. In fact, I think tens of petabytes have become quite normal and beyond. We are seeing people that actually do think about tens of billions of objects going into a single system. From a management perspective, the key thing that we can do to make this simple to manage is really to present a single namespace, a single system view, so that the operator views this all as sort of a logical system through a single pane of glass. Moreover, there's two other key problems. One is the idea that components under the covers fail, and they do fail continuously. So that's something that, from a storage perspective, you really have to worry about. You have things like rotating disks under the covers, and even motherboards and power supplies that fail. The thing that we want to do is sort of abstract the user's level of management so that they don't have to worry about those independent little elements, and let them instead worry about the pool of storage. So one of the things that we're seeing and we're starting to introduce more in these systems is really the ability to let it auto-manage or self-heal itself. So essentially the system is built with the expectation that components will fail, disk drives will fail, and if they do fail, the system detects that and it actually auto-heals or self-heals around the condition. So that for the administrator, they're not reacting to every individual element level failure, and instead they're thinking about doing this on a time basis, right? Perhaps every 2 weeks or every month or so, they're sweeping the system and replacing the components and swapping them out. Migration is another huge thing here, right? So these systems are growing rapidly. We're talking to customers that not only have 10 petabytes today, but they're saying it's going to double in a year. Well, how do you manage that over the course of many, many years, right? What if you have to maintain an archive for, we've heard 5 years, 7 years, we've heard 20 years, and we're even hearing lifetime, 100-year style archives. Well, in that amount of time, component technologies change in the blink of an eye, right? We need to start thinking about systems that can adapt themselves to multiple generations of underlying technology. So a very simple example, today's 2 terabyte and 3 terabyte drives are quickly becoming 4 terabyte drives. We need to build the system so that they can accommodate that, and moreover, so that they can work across multiple generations and even migrate the data automatically. There's a cute analogy I've heard that the migration problem is really analogous to painting the Golden Gate Bridge end to end. But by the time you're done, the bridge is grown, right? So you're really never done. You need to start thinking about the problem kind of on a continual basis. So that's the type of migration capabilities that we're starting to build in. Okay, and finally, data durability, right? This is really the key. If we're going to put our assets on active archive systems that are managing really sort of the gold copy of our data, this is the last copy of data. In many cases, we're not going to put anything on tape anymore. We really expect bit-perfect integrity for the data. I want to ensure that the data that I write today in 5 years or whatever the duration is comes back exactly the way that I stored it. So that means we have to preserve this as if it were a bit-perfect gold copy of the asset. So that means we have to do everything we can to look at things like corruption on the disks. Disks are actually generating bit errors periodically, so that's something that the systems have to mask over and protect against. And then moreover, there's the problem just of component failures, right? We mentioned disk drives failing and other components failing. We need to do that at a greater level than today's RAID technologies do. So one of the things that we have innovated in is this category of data protection called Erasure Coding, which is able to actually protect against an arbitrary number of component failures. So RAID does a very good job of protecting data against 1 or 2 drive failures, for example. We can dial that up. We can protect against 6, 8, 10, or beyond Simultaneous failures still make the data fully available and fully protected. And then finally, to do that without creating a huge amount of overhead, right? So if you look at data protection schemes, there is usually an overhead for protecting data. With RAID, there's a set overhead. With mirroring and replication, there's an even higher degree of overhead. With erasure coding, there's a way to do this higher level of durability without doubling the footprint. So that's the sort of the core innovation, is to make things as durable as you want, whether you want to dial in 10 nines of durability, 15 nines of durability, or beyond, but to do that with the least amount of storage overhead so that you're managing fewer disks, you're consuming less power, and ultimately your capital expenditure and your operational expenditure is as low as you want. So this is a very, very promising field of technology. So I think that's sort of the recap then, right? As we've looked at the requirements for creating these live archives and really arguing that tape is a difficult option to move against in the future. So we're starting to innovate a lot on doing this in a disk-based system. We think there's a huge value in companies looking at storing unstructured data on a live, active archive. And we're seeing a lot of uptake on that in these various industries. And especially doing this in a very durable and very cost-effective manner.